Welcome, class. This is Miss Birchfield, your instructor. In this lesson, we are going to introduce functions and a couple of some definitions. So we've talked about ordered pairs, and when we talk about a set of ordered pairs, we can refer to those sets as relations. And, given a set, for example, this set here, there's 3 points in the set, 0, 3, -1, 2, and -1, 3. Those three ordered pairs we can call a relation. Special relations are what are called functions. A function is a relation in which each value of the first component, of course, the first component, this is your x value, of ordered pairs, there is exactly one value of the second component, which is your y value, or we could say y coordinate. An easier way to think of it is for every x value, there is only one y value. For every x value, when you look here, notice that there's no repetition. So an easy way you can think of this as, in order to determine whether a relation is a function, look at your x values. Are any of those x values repeated? If not, then it's a function. If any of the x values repeat, then it would not be a function. So our x values here are 5, 6, and 7. We have no repetition of the x. So then this would be a function. So looking at some examples here, let's determine if each of these relations is a function. So we're just going to answer yes or no. So our first relation, we're going to look at our x values. We got an 8, a 5, a 9, and a 3. There's no repetition, so this one is yes, it is a function. Our second example, we have 9, -3, and 9. Notice that these 9s here are repeated. So that since our x value has a repeated number, this would not be a function. Our third example, we've got 2, 3, 4, 5. There's no repeated x, so this one is yes, it's a function. And our last example, -12, -10, and 8. There's no repeated x, so this one is also a function. So when we have relations, we can actually talk about the x and the y value, and we can name those values as the domain and range. Our x value we can name as the domain, and then our y value we can name as the range. Our x value is our independent value. So that means we can pick, whatever value we would like to use for x, but the y value is dependent on whatever our x value is. So whatever x is, our y value is dependent on what it is. So we can name our domain. Our x values 5, 6, 7 are our domain. And then our y values, which notice they're all 4, and notice that we did not repeat the 4, so our range just has the one number as our range. So we've already determined whether these were functions or not, so we're just going to name domain and range. I am going to, let's do this. All right, so domain, I'm just going to label D and R. We're going to list our x values. Now you can put them in order. You don't necessarily have to put them in order. So let's just make it easy on us, and let's just go by the order they are here. So we have 8, 5, 9, and 3 as our domain. Then our range will be 0, 4, 3, and 8. Our second example, our domain will be 9 and -3. Notice I did not repeat the 9. Then our range will be a -2, 5, and a positive 2. And these little squiggly lines, these are, they don't look a lot like what we have here, but we refer to this as set notation. Here we have a domain of 2, 3, 4, 5, and then our range will be 5, 7, 9, 11. And then our last one here, our domain is a -12, -10, and 8. Our range will be 5, 3, and we have another 3 that's not repeated, so it's just 5 and 3. So if we know, we just looked at a set of ordered pairs, but we can actually take equations that we know are functions and write them in what's called function notation. So what we do is, if we have an equation, what we want to have is, we want that equation to be solved for y. Just for example, if I took the equation of a line, like 2x plus y equal to 6, and I wanted to write this linear equation using function notation, what I would do is I would get this y by itself. So I would need to rearrange my x value. So I would have a -2x plus 6, and I now have an equation that I have solved for y. And linear equations, all linear equations except for vertical lines, are functions. So if we know we have an equation that's a function, instead of having y, we can use this notation, which is called function notation. This is not f times x. This is read f of x, is how we read this notation. This notation means that y is a function of x. So like we said previously, y depends on whatever x is. So that means that y is the dependent variable and our x is the independent variable. So you can think of this as a function machine. So let's say our function machine is our equation like we have here. So we can take anything for x. I can take numbers, I could put a different letter, I could put, a quadratic equation in place of my x value. I could input it and then get an output, which is the f of x. Anytime that you see this notation, all that notation is just your y value. So if I take this equation here, instead of writing y, I can put f of x there instead of the y, because I know that this linear equation is a function. Here, the second image or figure here shows you the function. So here's our function. All right, of course, this is a quadratic equation, and it's the function 0.014x squared minus 0.24x plus 8.8. So what we can do is, everywhere we have an x in the function, we can substitute the 30. If you just substitute the 30 where you have your x value and simplify it, then you get an output of 14.2. You can think of this as you're inputting the x value and you're outputting whatever the y comes out to be. In this example, we inputted 30, and then our output was 14.2. So it's basically, you think of it as an ordered pair. So what we're going to do is, we're going to take two functions. Notice that this function we've named f of x, and this function we've named g of x. The functions can be named any letter. If we have multiple functions, we want to name them using different letters. Another popular one, you might see h of x or c of x. That just names the function. So what we will do is we're going to input values in the x to determine the output. Our first one here, we're going to input 1 into f, which is our f is 7x squared minus 3x plus 1. So what we're going to do is everywhere we have an x, we're going to replace it with this 1. So I'm going to write 7 times 1 squared minus 3 times 1 plus 1. We're going to simplify. This is just going to be 7 minus 3 plus 1. Then, of course, 7 minus 3 is 4. 4 plus 1 is 5. So our output is 5. So you think of this like an ordered pair. The input was 1. The output was 5. So we just basically found a point on the graph. The second one here, we're going to input into g. Our g of x is 8x minus 2. We're going to replace x with 1. So we're going to replace the x with a 1. And then we're going to simplify the the right hand side. So this is going to be 8 minus 2, which is 6. So we inputted 1, we outputted 6. Our third example, we're going to go back to f, and we're going to input. So I'm just going to go ahead and save some time writing. So we're inputting a negative 2. All right, I'm going to go back to this f, and I'm going to replace x with negative 2. And then we're going to simplify the right-hand side. So using PEMDAS, we're going to do exponents first. So this is going to be 7 times a positive 4. I'm going to multiply a negative 3 and a negative 2 to get a positive 6 plus 1. We're going to do 7 times 4, which is 28, plus 6 plus 1. And then we're going to add all of these up. So 28 plus 6 is 34, plus 1 is 35. So we inputted negative 2, and we got an output of 35. And then the last one, we're going to go back to G, and we're going to input 0 where we have an x. So we're going to say 8 times, instead of x, it's going to be 0 minus 2. 8 times 0 is 0, so this is going to be negative 2. So our input was 0, and our output was negative 2. The last thing we will do is determine whether a graph is a function. So if we don't have ordered pairs or an equation, we can look at the graph and determine if it's a function using the vertical line test. So if we draw a vertical line, if a vertical line intersects a graph in more than one point, then the graph does not define y as x. Basically, that just means that it is not a function. So what I'm going to do, I'm just going to draw a vertical line. Notice that my vertical line hits this graph in 2 places, so this is not a function. If I draw a vertical line and we were to move that vertical line along that line, it would only hit it in one place. So this one is, yes, it's a function. Here, if I draw a vertical line and I visually think about moving that vertical line along, it is only going to hit that graph in one place. So this one is, yes, again, it's a function. And then our last example, if I draw my vertical line and I look, notice that it hits the graph in 2 places. So this one is not going to be a function. So no, this is not a function. Thank you for listening to this lesson, and I hope you have a great day.